Yeah, that's embarrassing. Apparently, I did not hit the go live button. Oops. So you all missed out on an introduction that I never made, according to you. It's alright. We're fine. Hello everybody. Welcome back. We're going to be continuing our Playdate shenanigans using the Swift programming language. This week we're going to be focusing more on UI work, mostly the clock. Maybe we'll get to doing some stuff with the box UI later. Sorry that I wasn't able to do last week. There was some stuff that just kind of came up that didn't quite work out. It's all good though. It's all taken care of. So we should be able to continue as normal. Now, as such, I obviously do not just sit here and twiddle my thumbs. There is some important things that I do need to kind of show off in terms of how the game kind of now works, because I kind of did a major refactor before we even look into the way that this whole thing works. So, let's go ahead and jump into the easel, and I'm going to show you what this looks like. So first, let me just attach our keyboard. Whee! So, previously, we had everything just kind of bundled in the update function. Which, I mean, is alright, but it's not the greatest thing in the world. So, I decided to change this up a little bit. So here's how the new system currently works. So, we're going to just make a box here. So we have a thing called a system. And each system has two important parts to it. We have the, I was about to say update, but no, it's called process. And then we have draw. Now these are two methods that we've defined, and each of them have respective jobs in their system. Process takes care of handling things such as like input, responses, and then just kind of interacting with the general environment. And this is important because this later sets up things for the draw call. So that way, if anything needs to be drawn, it will be drawn. So drawing does the actual rendering and calls the Playdate's screen APIs or something inside of Charlotte or something like that to actually draw things onto the screen. And so the way that this works is with the system, we have something called an iteration. And so all that this does is for a single frame, it'll just call process and then draw. That's all it does. And this just kind of allows us to kind of write things a little bit more simply, but also not kind of have our code kind of stuck together where it's both processing and drawing in the same space. Now, what's also important about the system here is that there may be some additional things that we have to rely on. So we have things known as subsystems, in which when it comes time to do processing and drawing, it'll call those internal subsystems to handle those as well. So that's kind of the major refactor that we've done here. So if I were to pop my keyboard back in, I'm gonna put the pen back in its fancy slot. Main. Alrighty. So if we were to look here, and if we were to go back to the main thing here, you'll see that we actually have our main game loop, which is now just a class in which we declare a couple subsystems. This one does stuff for the player, this one for obstacles, and then this one for the actual boxes. And all that this will do is it'll just take care of some other stuff that we normally used to do. such as kind of like checking game over states and whatnot, and then the drawing to handle actual drawing stuff. And this is where we're going to be doing most of the clock stuff today. But you'll see that it's no longer in the giant update function. If we actually look at setup, you'll see that now when we do updates, we're just creating a main game loop when we first start the game on the Playdate, and then we just call run managed iteration. This particular method is responsible for doing the actual calling every subsystem to update, as well as the main game system itself to update. So it does that process draw, process draw, process draw. So it's mostly helps with separation of concerns here. So with that in mind, now that we've kind of gone over the main gist of this, let's actually get to writing some clock code today. So we'll most likely be inside of this main game loop subsystem. So I remember where we last started, we were just trying to draw the clock onto the screen. So let's see. I think the last that I ran this was when I was actually trying to... Oh, that's interesting. Where did my clock go? Interesting. The clock has disappeared. Let's check to see that this is just not randomly hidden. Ah. Okay, yeah, I get it. Game over. That is peculiar. So are we even getting to this point? System log clock time. Let's check to see if this actually gets called. It may be possible that we're not reaching this part of the draw yet. No, we're getting there. So the question is, why do you not appear on the screen? Draw bitmap. I'm not doing anything with sprites here, so that should not be an issue. Position vector 2, 32, 32, flip bitmap unflipped. Let's go look at the clock frame again. Go to definition. Oh, we need to go to setup. That's what we need to do. Setup. Let's go look at our clock frame here. Is it table related? It may be table related. It might be. See if we can get a sprite loaded up here to attempt.asprite. That's not it. Okay, one moment. I need to browse for this file, because apparently it does not exist. I mean, it does, just not where you think it does. Forgot how this works. Did I put it here? No. This developer projects. Oh, package resolved new. Export as all frames, just the selected frame. Now we go to this developer. Source images, static clock. I forgot to change the file extension. That is supposed to be a pung. Okay. So let's go back to setup real quick. Gonna clean the project and then run a local build. No clock? Did we not call it? Images. Oh. Yeah, that's embarrassing. Graphics. Bitmap. Path. Images. Static clock. No. Okay, so it is not. It's not a table issue. Cool. We managed to figure that out. So I'm assuming it has something to do with the way that this draw is going out. Clock frame, position 3232. So I think it's trying to draw, but something's not working. Let's take a look at our run managed iteration. For subsystem and oh. It's probably the timing and when the actual main system's draw call's being done. Uh-oh, where's the player table? I guess we're making a clock subsystem. This wasn't what I was anticipating. Final class clock subsystem, which is a subsystem. Override func process. Override func draw. Okay. And then we just kind of smack this here. Okay. It is screaming because we need to restart the LSP server. So we can take this, put you in the process. And then we just need to take this out. And put you here. Cool. And then at the end, we'll make this a guard clause later, but hopefully that should do the trick. Da, 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 da. Yeah, okay. So, for those that are confused, the way that the game system works when it comes to managed iterations, it'll always call itself first, and then it will call its subsystems. So, because there was stuff that we had to deal with sprites, right, and because of the way that this whole drawing system works, it'll try to draw itself first, then it will try to draw all of the subsystems that use the Playdate Sprite APIs. Then it'll tell the Playdate system to update those sprites. And then at the end, it'll check for everything else. Since there is some stuff that... there is some pre-stuff here that the game has to worry about beforehand. That's why it's called here. So by moving this into its own clock subsystem, this now renders as the last stage in the overall rendering process, and that's why we had to go through a whole series of shenanigans to get that to work. So now I think this should work as normal. Yep. So it turns out we didn't actually need to do anything for the static clock here is useless. That's fine. Package resolve.swift. Yep, we will commit those changes, and then we will update the clock subsystem as well. Add clock subsystem. Apparently, if I can spell. System. Push. Are you for real? Are you for real right now? Oh, brother. Yeah, I know. I was gonna say that we had this set up, but apparently not. Apparently I still have to use Sublime Merge to push. That's mildly annoying. I forgot that when it comes to HTTPS stuff, it doesn't save your username and password. Thanks, VS Code. Real cool. Okay. So, we're now back on track. Now we just need to figure out the different phases of the clock here that we need to worry about. Ooga booga. So, we can use something here, right? I'm going to check and see what we have in terms of... I think right now we just kind of hard code this to 60. Yeah, we always hard code to 60 right now. So, I guess all we need to do is just divide by 60 to get our percentage, right? var percentage float should just be game data dot time remaining divided by 60. Cannot convert. Okay. Now, how are we going to do this? Well, I suppose in here we can also write a method to handle some of this. So what we're going to do no, never mind. We're not doing that. We're just going to write it up here. Private func get frame for percentage int. So we're just going to switch on the percent remaining. Default return 0. So we have case, because right now we just have it in fourths, I believe. So this is around the 75% mark, I think. 75. Or I guess in this case it would be 0.75 to 1. I could be wrong on this. Must have at least, thank you. Return 1, and then case 0.5. Or I guess in this case it could be 4.9. Return 2, and then case 0.01 to 0.25 would be return 3. You know what, we can make this 0.99. Case 1.0 would be, okay, you know what, yeah, so case 0, return 0. That should be very straightforward there. Though I think we can just do this now, right? Do a switch expression. Yep. This should actually be 4. You love to see it. Okay, so now we get a frame for percentage. If let clock table, or in this case we'll just say guard let table equal game data dot game resource dot clock table, else return false. And then we can say clock frame is table dot bitmap at, let's make this return a cint, just to make this happy. Get frame for percentage. This is probably very inefficient, but it should at least let us see how this looks. Okay. Okay. You got seriously injured. Yeah, I know, thanks. This time, let's not die. I could just comment out the palette subsystem, so we're not having to deal with that. Yeah, actually, let's do that. See, this is the nice thing about having it the way that we have this set up. So this should no longer be worried about. So we could just sit here and let this run. The power of separation of concerns. Oh, but now this isn't updating for some reason. Oh no, it did. I guess it just wasn't in the specified value. I guess. That's particularly interesting. Malloc pooling. No, I don't want memory profile. Oh, I guess maybe that is the option we want. Huh. Though we did get a you couldn't complete the mission in time, so that does seem to work at least. Nah. Yeah, okay, we got some values swapped around. I think that's what the issue is. So if I were to think about this, so let's go back. So 0.75 to 0.99. Okay. Let's try this again. So we know case 0.75 to, or I guess in this case it would be 0.76 to 1. We'd get the first frame. And then case 0.75, 51, that would be frame 1. Case to 0.26, that would be frame 2. Case 0.25 to 0.01 will be 3. Case, and then our default will just be 4. I think that's fairly reasonable. We'll see how that looks. Let me get the profiler up as well, so we can just kind of see how the memory usage looks. Automatically refresh. That would be helpful. We're not using any extra memory, so cool. That was my main concern with the rewriting the frames. So we may not even need to. Maybe, I don't know. We'll see. Though, this is working. And the frames are updated correctly, so I must have just done my math wrong when I initially wrote the first thing. This is good. So now we're getting the clock, and that just kind of sits there in the corner. Yay. And no extra allocations. So what if I said let frame equal table.bitmap? Yeah, so we'll say guard let frame. Nah, I know what we can do. Let frame else return false. And then we're just gonna say Playdate system log no block. At this point, we may not even need to store the thing anymore. Which, I mean, that'd be cool. Da, 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 da. Let's get our memory pool up. I'm going to restart this just so we can see how this looks from moment 0. Okay. Heap usage isn't going up, so I guess because we have the table already stored in memory, we don't actually need to worry about fetching a bitmap from it, because I guess the system already knows to refresh it at a specific time, which is good. That is good. Yeah, that looks very playable. And then just wait for this to time out, and... Oh, I didn't hit automatically refresh. Well, let's run this one more time. I want to see. If you're wondering, I'm staring at the malloc log at the bottom here. Because I remember last time that we were doing some stuff, I don't remember how many streams ago it was, but we were starting to see some memory increases just from silly things with like formatting strings. So that's why we're kind of just doing it this way. I mean, the clock was also a piece of text too, but that was more of a embedded Swift limitation we're dealing with right now. Though, it does look like it'll be changing in the future, which will be really nice. So we can use that system again. Personally, I think the clock is just a little cuter, but sweet. Okay. That's looking pretty good. So I suppose we can save ourselves an allocation here. So we just need to go back to data, and then we can just get rid of this, because that's no longer actually necessary. And then if we go to setup, we can just remove that part from the thing. And I think that should help cut down too. So let's rerun this. Plop. Refresh. We're going to restart. Yeah, I mean, I guess that didn't really change much, but... this is good, at least. Nice. Managed to save some time there. Close others. So I do want to change this, though, into a private var percent remaining and a private var frame for current percentage. Make this a cint, and then we just say frame for current percentage. Cool. And then this should work the exact same way. We'll run this just in case. We don't need to worry about the memory thing, but it cleans it up a little bit. Yep. Nice. Cool. So I guess let's get that committed underway too. Commit. And then we're just going to go here to push it. And then that should do the trick. Nice. Woo! Great work, team. Let's move you out of the way. So I guess this is where our next step is. We're going to be doing the box collection thing. Now, supposedly we do have some insight on what needs to be done. If we were to look at here, unsafe, mutable buffer pointer dot allocate, and then capacity. How big do we want this to be? Element could not be I mean, do we need to do the box stuff right now, though? Things to think about. Also, yes, I just realized that I'm still streaming the easel mode, even though we're not supposed to be doing that. But what I am going to do, though, is because we're still at it here, actually pull this up. Boom. So this is what we're actually looking at here. So this is the actual PR that adds the actual string support, right? Which would enable like interpolations and then printing with stuff and then doing dynamic things with strings like we normally do. But we can't do actual stuff like this. So printing at arbitrary types, we don't really do that. String interpolating via type reflection, no. We don't do that either. Converting arrays, dictionaries into strings with their elements described. We'll negate those gains by bringing back Unicode tables. Interesting. Yeah, so it looks like they actually added a lot here. Embedded print. String.swift. I wonder what actually makes the change work in here. Not sure. But ideally, I think we'll probably wait for this to get merged before we actually display the number of boxes back on the screen. So I guess that's something we'll have to wait on. So I guess we'll come back to this later. I'm going to punt that for now. So I guess the next thing is to look at an overlay. Because, right, when we run the build, switch back to main, the clock is just kind of floating out here. Ideally, we want to reserve this bottom area for like proper UI. So I guess let's see what we can do about that. It's like, this is actually a stream of... Actually a stream of doing artwork. I don't know why I had a hard time saying that. So here's what we're going to do then. We're gonna pull up a spray again. I just love it when I get a dialog box for that right away for Steam. Easel. Okay. Now, one thing I do need to check real quick is because unfortunately these bookmarks I think point to local documentation on my Mac. Designing for Playdate. I'm trying to remember what the resolution is. 400 to 30. And because I want to scale this up, so 400 to 40. So this just becomes 200. This should just become 120, if I were to guess. Yeah, cool. All right, so this is the display. Now, we're going to need a rectangle tool, methinks. Let's see, how big do we want this to be? 18 pixels. I think 20 is okay. Though I just realized this is not. There we go. Cool. And then we just try to get the clock centered into that. And then we should be fine. Well, why do we need to do artwork if it's just a giant rectangle? We know how to draw rectangles already. I think we can stick this in the clock subsystem too, real quick. Just for poops and giggles. Playdate dot graphics draw rect, right? So x we know will be 0. Screen No. Game data screen bounds y minus 20. Width cannot convert to int 32. Why do you do this? Thank you. Width. Game data screen bounds x. And we need to make this an int 32 as well. Int 32. Well, actually, this one I don't think we need to actually worry about. We can just say height 20, and that will be fine. Right, and then color, yeah, we'll be fine there. Let's see how this actually looks. Real quick. Da, 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 da. While you're doing that thing, I will go over here and do this thing. Okay. That's actually a little small. How about we make this 24? My surface is screaming at me. I can hear it. You probably can't, but I can. Yeah, 24 is fine. And then we can just shift this down a little bit, right? We'll make this 24y8, I think. Let's see how this looks. We'll just have to get a feel for it. Oh, that was a little too much. 16? No, I think this one needs to be... Or, you know what? We can make this 20, I think, and that should be centered between the 2 points. Boom. Just how I like it. Though I think I'm using the wrong version of DrawRect. Play.date dev. So you can come with me as we look at the docs. Graphics. Geometry. Fills an ellipse inside the rectangle. Yeah, okay, so I guess we need to do that up here. Fill rect. Color. LCD. Playdate. Graphics. Color dot. I guess we're just guessing. I'm gonna guess 0 for white, 1 for black. Psych, it's the other way. Okay. We're not seeing any boxes behind the thing anymore, so we did a good job. That is looking good. Now we do have some reuse here, but I think this is fine. Maybe we can move these out. let width equal width, and then that should be fine. Boop. And boop. Then we just do the same thing here. Y pause and width. This should run the exact same. Cool. This is working. So let's commit this. Draw basic HUD. Overlay for UI. Push. So, I guess with that in mind, I will probably need to do some extra research on the drawing app, or not the drawing and filling rectangles. We just did that. Oh. Whoops, I forgot to show you the actual code for what I just did. And the actual thingamado. Whoops, my bad. I really need to set up the automatic switcher on this. But you can see here that this is working as intended, and we don't even have to worry about the boxes being displayed a certain way. So we're good there. Now, that in mind, if we go back to easel here, so we have the overlay more or less done. It's really a simple, just draw a thing. It's just the boxes collected that we'll need to do for improving the UI. That, and I guess the crank indicator. So the next thing probably will be handling like the actual levels and stuff, because right now we have it hard-coded. But also like displaying like a title screen and stuff. So that's probably the next section that we're heading into. I don't know if I want to stick with the built-in JSON content, or if I want to try getting k:rt to play nicely under the Playdate for Swift. We did get it working for C though, so perhaps that's something we can actually work on. But that'll be fun to play around with. So, I guess with that in mind, if you enjoyed today's little stream, feel free to hit the like button. If you want to stay up to date with any future streams of me working on this game or anything, sorry, there was a fly, anything Playdate related, you can also hit the subscribe button to get notified of that, or hit the little notification bell on the live stream thing to get notified there. And I think, yeah, that pretty much wraps it up. Thank you all. Take care.